So here I am. I'm Enrico Livelli. I work at DataStax in the Luna streaming team. I'm also part of Apache Pulsar project as a commuter. I'm a member of other Apache projects like Bookkeeper and Zookeeper, and currently I'm the VP of Apache Creator. Today I'm going to talk about testing distributed messaging systems. That's very hard. I want to introduce Fallout. It's an open source software for distributed testing. We will run through the Fallout architecture. I will introduce NoSQL Bench. We will see how you can design a Fallout test. How can you can use Fallout with Pulsar, and we are going to see a live demo and wrapping up with future works. Let me start the Fallout test now. We are going to see it later, but it takes 20 minutes. So hopefully we are going to see the end of the test before the end of the presentation. So let's start talking about distributed tests. You know about classic types of testing: unit test, integration test, system test. With the unit test, usually you test a function, a method, a class, a very small software component. With an integration test, you start a more complex system and usually interact with the system using some API. For instance, in Pulsar tests, we start Pulsar service and we use the HTTP API, the binary protocol API. And in system test, you start the product in a way that is more similar, like the way you run in production. For instance, you can use Docker. But in distributed system test, the approach is it's very, very different. For instance, you launch end machines, real machines, VMs. You deploy the real application using Helm or some script that uses SSH to deploy a tarball and deeper, run a setup procedure. Then you run clients that exercise the system. You can inject failures, and you can perform system-wide assertion in the end of the test or in the middle of the execution. You want to create reports, performance reports, reports about the failures. You want to compare the reports of one execution against the previous execution, or you want to run the test against one version of your software and another version. You want to compare the behavior of the system, or you want to run longevity tests, like running the test for hours and see that everything is working well. So here comes Fallout. Fallout is an open source project, Apache license, that we created at DataStax. It's on GitHub. Initially, the project started for Apache Cassandra, but now it is a general purpose tool. We didn't change Fallout in order to use it with Pulsar. We are simply using the basic feature of Fallout. And with Fallout, you can design repeatable experiments that run with real clusters. We will see in the demo that you code the test using a single YAML file. It runs a deterministic setup run check. So you install, you run some workload, and then you check that everything went well. It supports Kubernetes natively, so you can use any tool, and kubectl, you can run Kubernetes jobs. It is integrated with GKE, but also it is modular, so you can add support for other engines. And actually in DataStax, we have custom modules for running the tests in other cloud systems. You can monitor your longevity test, and you can integrate it with Jenkins or GitHub Actions. And one of the coolest features is that it aggregates logs in real time from all nodes and pods. NoSQL Bench. NoSQL Bench is another open source project. It is on GitHub. We are deploying Docker images on Docker Hub, both for NoSQL Bench and for Fallout. And basically, with NoSQL Bench, you perform two tasks. You generate load, you shape your load, you generate load, and you measure performances. And you can run the test and distribute the client of your application over multiple nodes or pods. And then you can aggregate the results in the end. It supports out-of-the-box many drivers for Cassandra, MongoDB, other NoSQL databases, but there is a driver for general purpose JDBC, for general purpose HTTP calls, so you can exercise your web services. It supports modern messaging systems like Kafka and Pulsar, but recently we added a module for JMS. And for every driver, it tracks basic metrics, so throughput and latency, but also other specific metrics. For instance, if you test Pulsar with transactions and you perform commits, there is the metric about the time spent in commit, for instance. It is integrated with the metrics and with Graphite. So it produces standard HDR files that you can elaborate. You can process after the execution of the test and create charts, reports, or send them to Graphite. So for a distributed system test, you need two things. You need to deploy your application somewhere. So we're talking about cluster deployment, and then you have to run the workload. Regarding cluster deployment, we have three key components. We have provisioners, configuration managers, and providers. The provisioner is about where to run the test. In our example, we will see the GKE provisioner that basically creates a cluster on GKE. And the configuration manager is what? The configuration manager is something that installs your software. There are configuration managers that are really out of the box, like Helm support, but you can add your own configuration manager. You can use a bash script to deploy software and configure whatever you want. And providers are the internal glue of every component. For instance, if you want to run kubecontrol, you need the kubeconfig. So there is an internal component that provides the kubeconfig file for the cluster that was created by the provisioner. Sorry. Then let's check that the test is running. Basically, now Fallout is deploying the Pulsar M chart, and we are waiting it for be up and running. I will explain later. Execution. So you specify a workload. A workload is made of modules. Modules are your actions, something that you do against your system. And you can configure phases, and phases define the general execution model. You can combine parallel phases and sequential phases. For instance, you can create a topic, produce messages, consume messages, and then verify. But you can create topic, produce and consume, and concurrently you can fail some parts of the system. And in the end, you can verify, but you can verify at any time. The third part of the workload is the artifact checker. You can add artifact checkers that summarize metrics, produce charts, reports, send data to other systems for post-processing, or verify logs, or download artifacts from the pods and verify that everything went well. Let's see a typical YAML file for Fallout. In the meantime, Fallout is working for us, and the Helm chart is still setting up. Every fallout test has a bunch of parameters. For instance, you can choose the Pulsar version you want to test, and then you define the provisioner and configuration managers, the number of nodes I want to deploy in GKE, and I want to install an application with Helm. I specify Helm chart, where to download the repo, and I can specify the values. We will see a real example later. And then you can define the workflow. This is really a simple YAML file, so very, very straightforward to write. In our sample workload, we will have a create topic phase. It's a simple Kubernetes job. We will see the manifest later. For instance, you can use a Pulsar admin to create a partitioned topic, and then you can produce messages using NoSQL bench, but you can also use a Pulsar perf or use your custom application, whatever you want. In this case, of this particular YAML file, the produce messages module will run together with the consume messages in parallel. This is an example of checkers. The no-fail checker simply verifies that every module completed with success, and the artifact checkers, for instance, in this case, we want to generate a char aggregating all of the HDR files generated by NoSQL bench. Let's see our test that is running. Now the end chart has been deployed, and now we are deploying ChaosMesh. I'm going to talk about this later, but it is important that the test is running because it takes time. So testing Pulsar with fallout. Why we started to use fallout for Pulsar data stacks? Because we want to guarantee the stability of Pulsar, and we will really care about the current master branch of Pulsar, of Apache Pulsar, and we want that to be really stable and in good shape. So we are using it to guarantee the stability of the Apache Pulsar repo and our data stacks distribution of Pulsar in streaming. That basically the same. And we want to perform continuous testing of Astra streaming cloud environments. That is another cloud environment at DataStax for Pulsar. And so basically we perform two kinds of tests. Release stability validation. So before releasing, cutting a release of Pulsar, before voting a release on the Pulsar mailing list, or before cutting a release of Luna streaming, we want to test cluster-wide features in a real Kubernetes environment, like testing Kubernetes functions run on Kubernetes pods, testing with authentication, or recently we tested the rootless Docker images. We perform longevity tests or tests that simulate failures on the bookie, Zookeeper nodes, broker, proxy. You can simulate failures in the network, in disk, slow disk. We simulate rollout restart. So basically the question is, if I restart the broker, will the system come to a stable state? It's an easy question, but it's not easy because there are so many things that happens in a real Pulsar cluster with many nodes. So we want to test this, and we want to have a reproducible way to test this. Also, we can simulate upgrades. And the second type of test is about benchmarks. So we are literally hunting for performance regressions. We are using a tool named Hunter. And we are running daily tests against the current Apache master branch. So we are building the current master branch and pushing it to a pipeline that runs benchmarks with Fallout, NoSQL bench, and verify that the new commits did not introduce any regressions. And we are comparing different releases. Currently, we are comparing Pulsar 2.6, 2.7, 2.8 now, that has been just released, and current master 2.9, and our Luna streaming releases. Or we can perform benchmarks against a given setup. So what are the expected performances of my Pulsar system if I have a cluster with a given size, given type of machines, the given spatial configuration? Okay, you can configure your test, you can run, and you can see how it performs. Or sometimes we use Fallout to reproduce performance issues. So you load your configuration for your Pulsar cluster, you run your workload. So the live demo is running. ChaosMesh has been installed. So let's talk about ChaosMesh. ChaosMesh is a very interesting tool for this kind of test because it allows you to perform experiments like injecting failures, like killing pods, simulating slow networks, slow disks. And in the example that we are going to observe to see how it goes, we are starting, or we already started a 6 nodes cluster on GKE. We deploy the Apache Pulsar 2.8 cluster using Helm, the Helm chart, with 1 broker, 3 bookies, and 1 proxy. We configured 222 replication parameters, so every message is written 2 times. So we can tolerate at most 1 bookie failure at a time. This is important to know. We deploy a NoSQL bench pod, deploy ChaosMesh using the Helm chart for ChaosMesh. We create a partitioned topic. We produce and consume messages concurrently, and at the same time, we simulate bookie pod failures. 1 bookie at a time. This is important because with 222, we can only tolerate 1 bookie failure at a time. We track time series for latency, and we calculate throughput. And in the end of the test, no error must be reported by producers and by customers. You can find this file on GitHub. In the end of the presentation, I will give the references to all of the files that I'm using for this demo. So let's run through the live demo. I'm going to show you the Fallout web user interface. We will see the templates, the parameters, and how it works, the live log aggregation. And if you are lucky, we will see the broker logs in the end of the presentation. So this is the live log taken from the main Fallout server. We created the topic. So let's run through the template. It's a YAML file. I'm going to make it as large as possible. For instance, the parameters for this test are the image test. We are testing the Pulsar Docker image 2.8. You can run the test against any Pulsar Docker image. We're using the client tools from the same Docker image. We are using the Luna streaming Helm chart. In the GitHub repo that I'm going to show you, the templates works well with the Luna streaming Helm chart and the Apache Pulsar Helm chart. They are very similar one to each other, but there are some little differences. 6 nodes, 3 bookies, 1 broker, 1 zookeeper. It's really straightforward to understand how it works. Replication parameters, we are producing 1 million messages with a parallelism of 10 threads. On the producer, we have only 1 pod that runs the producer with 10 threads. We created a topic with 10 partitions, and we are injecting failures only on the bookie. No rollout. We are injecting this configuration to the broker, but we only have one broker, so no, not so much fun. Then we have the definition of the cluster. You can define local files. You can define the files inside the single YAML file, but you can refer to external files or external GitHub repositories. For instance, this is the manifest for the PodChaos experiment. So basically, this means that we want to kill a pod that matches these selectors or a bookie. The failure must last for 30 seconds, and it should happen every 2 minutes. This is the manifest for the Kubernetes job that creates a topic. Basically, we are using Pulsar admin topics. We are passing all of the environment parameters. And this is the template for the values to pass to the Helm chart. For instance, here you can see that you can override the image version for all of the components. We're not starting the functions. There are tweaks to adapt the values to the ASF Helm chart and to Luna Streaming Helm chart, because we want that it works out of the box with both of the charts. So let's see the provisioner. Provisioner GKE. This is the number of nodes. And configuration manager. This is something that is installing the software. So we are installing Pulsar with Helm. We are installing the Kubernetes log node configurator that basically it will dump the logs from every pod in the end of the execution of the test, and so you can post-process the logs. This is the configuration file for NoSQL bench. The interesting thing is the subscription type for the consumer. We are only running one consumer pod, so it's not a big deal. And for the producer, for instance, we are using the block HQ full option. Then we install ChaosMesh using Helm chart. We are installing NoSQL bench. Then we have the definition of our workload. I'm taking a look to the logs in my secondary screen. This is the setup for ChaosMesh. Then we run a Kubernetes job that creates a topic, and the definition of the manifest is up above. Then we run concurrently produce messages module and consume messages module, and concurrently we are injecting bookkeeper failures using kubectl apply, and we are applying that manifest that we saw up above. We wait for ChaosMesh to finish killing the pods before collecting the logs. And then we want that no failure happened, and we want to generate chart a report. So let's see if the test finished. The test is tearing down, so fallout is basically destroying the cluster. Let's wait for it, and let's move forward with the presentation. We will see the results in the end. I want to talk about this Pulsar release validation toolkit. It's a GitHub repository with a couple of templates for fallout and a useful bash script that basically you run the script, you give a Pulsar Docker image, and then you run the test. There are examples for running tests, for testing Pulsar functions on Kubernetes, doing stress test, test about using the Pulsar M chart or the Luna streaming chart. You can use Pulsar from 2.7 to and new versions, because you can also use it for 2.6, but Pulsar Perf and Pulsar Client changed a little the command line interface parameters, so you have to tweak the templates. There are examples for running NoSQL Bench, for running ChaosMesh, create a custom configuration of the broker, or to run standard client tools. So Pulsar Perf, Pulsar Client, Pulsar Admin. It's really simple. You can use the template, you can modify it, and you can run it. Okay, let's see. Okay, we can see the logs for a previous execution of the test, but time is running out. Basically, this is the same test that I executed a couple of 1 hour ago. We still passed the 222 as replication parameters, and we injected failure to the bookies. So this is exactly the same test. Fallout offers this Fallout shared log that aggregates all of the interesting logs in the system in real time. Fallout errors collects only the things that happen to be, that look like problems. Then many logs from all of the internal components. We are interested in the logs for the broker because we are injecting failures to the bookies. So I want to see here that the broker saw a problem in one bookie at a time, and it recovered from it. Okay. As you can see here, after some time, ChaosMesh decided to kill the pod Pulsar Bookkeeper 1. The test, the failure was running for 20 seconds. And then after some other time, he decided to kill the Bookkeeper 0 pod. So these are the broker logs. We have, during the execution of the test, we had 2 problems. Here you can see that Chrome finds two sections. Okay, so PodMesh generated the problem, and the test succeeded. So the consumer actually was able to, oh, this is our test, it passed. So the NoSQL Bench consumer was able to consume the 1 million messages without problems. We can see, for instance, the generated report for latency and throughput. Okay, so let's select produce messages, execute. So this is the throughput during the execution of the test. We can see, for instance, latency. No particular problems during the execution of the test. This is really interesting for me. So, okay. Sorry. Okay, some future works. We started to use Fallout to test the Pulsar and to ensure that Pulsar is stable, and we want to help the community to verify that Pulsar is stable at every release. Some useful follow-up for the Apache community. It would be interesting to contribute the corpus of tests that we are running to the Apache Pulsar project. Currently, in that example repo, you can find some useful templates to get started, but we have more and more tests, so we can share it with the community, but we are running them every day against the current Apache master. I would like to give to the community an easy way to test Apache Pulsar with real distributed system test, because if you are a developer, you want to contribute a fix to Apache Pulsar, and you want to test that you're not breaking things. For instance, recently we worked on Kubernetes. We had to update the Kubernetes client for Pulsar functions, and there is no integration test or system test currently in the Apache Pulsar repo that really runs Pulsar in Kubernetes. Currently, it is very difficult to deploy such kind of test. And also, if you want to run this test, you need at least 3 machines if you want to run something that is really useful. So, yes, it will be great to have such tools available for the community. And actually, you can use this repo that I'm going to give you the references in the end of this talk. It would be great to integrate Fallout with pre-release validation workflow. So before validating the release, it would be really interesting to have a step in the release procedure to validate the stability of the release, or also to add a pre-commit validation for the pull request. Fallout is deployed with the Docker image, so the only thing that you need is a cloud account, a GKE account, in order to run the test. I would like to note that Fallout and NoSQL Bench are a public open source project. Anyone, you can contribute to this project. NoSQL Bench is widely used. Fallout is still young, but it is very useful, and it is already used in the Apache Cassandra community. Okay. I would like to leave you some references. This is my LinkedIn account. You can find me on Twitter, on the Apache Pulsar community, on Slack, on the mailing list. These are the links for Fallout on GitHub. Here you can find the documentation, the full documentation about how to run Fallout. This Pulsar Fallout repo is the repo with the templates and the script to validate a Pulsar release. This is the link to NoSQL Bench. And if you are really interested in Fallout, you can see this wonderful tutorial about the internals of Fallout. My colleague contributed last year. Okay. Yesterday we launched Data Streaming. So if you want to try to use Pulsar pay-as-you-go, you can try it. This is our latest contribution to the community and the ecosystem. So this is all. I'm done.